Now there's some exponential equations that if we try to set both sides to the same base, we can't do that. Here's just two examples. 4 and 15 don't share a common base. And likewise, 10 and 120,000 don't share a common base. So what do we do? Well, logarithms can be very helpful for us in trying to solve these types of things. So for bases that are not common, in this particular case, there's no common base in either one of those, what we're going to do is we're going to take the natural log of both sides. Because again, whatever you do to one side of the equation, it's good as long as you do it to the other side. So let's take the natural log of both sides. From there, I can drop the x down. How do we isolate the variable? Subtract or divide both sides by log 4, natural log. So x equals the natural log of 15 divided by the natural log of 4. Kind of slick, isn't it? Now we can solve that. This is an exact answer. Natural log 15 divided by natural log 4. And if we want to get an approximation, we get approximation where we can use a black box. And it's approximately 1.95. So when we can't find a common base between two numbers, let's consider using logs and take the logs of both sides. When one of the bases is not a common log, then we're going to use the natural logs. On this other one, notice that the 10 is a common log. So in this one, we'll take the log of both sides. So what do you think we're going to do next? That's right, let's drop the x down. Whoops, sorry, not x equals, but drop the x down. And then isolate the variable. So x will now just equal the log of 120,000 over the log of 10. And what do you notice about the log of 10? Since it's a common log of 10 is just a 1. So this just equals the log of 120,000. That's the exact answer. You can plug it into the black box and get an approximation if you so choose. But that's an example of how we can solve an exponential equation when they don't have like bases or we can't find like bases. That's what logarithms can help us do.